Welcome to the course Compiler Design. In this lecture, we are going to discuss about the first phase of compiler, that is lexical analysis. So in this lecture, we will discuss about the role of lexical analyzer in this lexical analysis versus parsing is nothing but syntax analysis. Then tokens, patterns, lexemes, definitions of all these and with examples. Then how to define attributes for tokens. Then what are lexical errors? So lexical errors are errors related to lexical analysis phase. So the role of lexical analyzer, all these topics are going to be covered. So now let us recall once lexical analysis. During phases of compiler, we already reviewed lexical analysis, what is its role, what it produces as output and what it takes input. So you can recall once again, lexical analysis we know, which is the first phase of a compiler, which takes the modified source code from the language preprocessors. So before compiler, we have preprocessor. Preprocessor takes skeletal source code that can be converted into normal source code that can be considered as the input of lexical analysis. So here the lexical analysis is the first phase of compiler. It takes the modified source code from language preprocessors that are written in the form of sentences. The lexical analyzer breaks these syntaxes into series of tokens by removing any white space or comments in the source code. Lexical analysis not allowed white spaces, comments, a new line tab, etc. So the given source program that can be broken into series of tokens. We know what are the tokens. The tokens are identifiers, keywords, constants, operators, etc. These are all the outputs of lexical analysis or scanner. So lexical analysis is also called as a scanner, other name of lexical analysis. We can also produce lexical analyzer automatically by specifying lexeme patterns to a lexical analyzer generator. So what is a pattern? What is a lexeme? Then what is a token? All these definitions we will see. A lexeme is nothing but the characters that are presented in the given source program. Whereas a pattern is nothing but specifying a description of lexeme, which denotes a token. Then a token is nothing but sequence of grouping of characters. So these are all the briefly about all these. Then we will say the exact definitions and examples also. So now here we can also produce lexical analyzer automatically by specifying the lexeme patterns to a lexical analyzer generator and compiling those patterns into code that functions as a lexical analyzer. So we have one automatic lexical analyzer generator tool, which is called as Lex. A lexical analyzer generator called as Lex, also called as Flex. So Flex is the one of the latest tool name in a more recent embodiment. So this will occurred in Linux environment as an inbuilt tool. So one of the example of Lex tool is this Flex tool. In compiler design laboratory also, this experiment will be demonstrated. So then the role of lexical analyzer. As the first phase of compiler, the main task of lexical analyzer is to read the input characters of the source program, then group them into lexemes. Lexemes further produces tokens and produces as output a sequence of tokens for each lexeme. That means in the source program, each and every given character, it gives what is its token. Then the stream of tokens is sent to the next phase, that is parser. So parser also called as syntax analysis. So now the stream of tokens will be treated as input to the next phase, that is syntax analysis or parser. So it is common for the lexical analyzer to interact with the symbol table as well. So the role of symbol table in the phases of compiler, which is used to store the information about identifiers. So the phase wise identifier names are stored in symbol table. So when the lexical analyzer discovers a lexeme constituting an identifier, it needs to enter that lexeme into the symbol table. So by identifying the identifiers, then those information can be stored into the symbol table. In some cases, information regarding the kind of identifier may be read from the symbol table by the lexical analyzer to assist it in determining the proper token. It must pass to the parser, that is the syntax analysis, second phase of compiler. Some cases, the information about tokens already stored in the symbol table regarding identifiers and their values. So directly, so it can read from the symbol table by the lexical analyzer, then it sent to the next phase, that is parser or syntax analysis. Then if you can see the diagrammatic representation of the role of lexical analyzer in the compilation model. So here mainly the lexical analyzer interacts with its immediate phase, that is parser or syntax analysis. So interactions between the lexical analyzer and parser, the following diagram shows. First, the current phase is the lexical analyzer, which takes input as the source program. This is input. Then it produces tokens to the parser. Then whenever parser needs to get next token, so it interacts with the lexical analysis by using the method get next token. So then the parser takes input as token, then produces the tokens into tree structured form, that is hierarchical form. Then those will be given to the next phase, that is semantic analysis, that is third phase of compiler. So here parser, also called as syntax analysis or analyzer, which is second phase of compiler. Second phase of compiler. So now here you can see symbol table is commonly connected to both the phases, lexical analyzer and parser. The information about tokens, that is regarding their identifiers and their values, are stored in the symbol table. All the 6 phases are connected to the symbol table. In the big picture of phases of compiler, we already seen the diagrammatic representation. But this diagram shows the role of lexical analyzer in the phases of compilation model. So then interaction to the next phase, that is parser syntax analysis. So the role of lexical analyzer, we have to take this diagram. Then here input, then token is the output of lexical analysis. Then that will be given to the input to the parser or syntax analysis. Then whenever parser wants to next token by using get next token method, it takes from the lexical analyzer. Then the output of parser or syntax analysis is hierarchical representation of token that will be given to the next phase of the compiler, that is semantic analysis. This diagram shows the interaction between the lexical analyzer and the parser. So now commonly the interaction is implemented by having the parser call the lexical analyzer. So the call suggested by the get next token command. In the diagram we already seen the role of this command, get next token command. So causes lexical analyzer to read characters from its input until it can identify the next lexeme and produce for it the next token, which it returns to the parser. So till it gets the next token, so the lexical analyzer scans the input by taking the method or command get next token. So since the lexical analyzer is part of the compiler that reads the source text or source program or source code, it may perform certain other tasks besides the identification of lexemes. So one such task is stripping out comments and white space. So I already mentioned in the lexical analysis, it won't allow comments and white spaces like blank, new line, tab, then some other characters that are used to separate tokens in the input. So these are all omitted, stripping out. This is the other task of lexical analyzer, as the regular task is identification of tokens. So now there is another task also, that is handling errors. Another task is correlating error messages generated by the compiler with the source program. So during lexical analysis, whenever errors are occurred, those are called as lexical errors. So those error messages are generated by the compiler with the source program. Then you have to handle those errors. For instance, the lexical analyzer may keep track of the number of new line characters seen, so it can associate a line number with each error message. So that error message is also one of the component connected to the pages of compiler, that is error handler, which stores all the pages error related messages. Then in some compilers, the lexical analyzer makes a copy of the source program with the error messages inserted at the appropriate positions. So by taking error message combination, if the source program uses a macro preprocessor, which is the expansion of macros, may also be performed by the lexical analyzer or analyzer. This is the another task of lexical analysis. So the first task is the identification of tokens. The second task is stripping out comments. Then the third task is identifying the error messages. Then the fourth task is making a copy of the source program, including error messages. So these are all the some of the tasks of lexical analysis. Sometimes lexical analyzers are divided into a cascade of two processes. So first one is scanning, second one is lexical analysis. Proper is the more complex portion, which produces tokens from the output of the scanner. So scanning consists of the simple processes that do not require tokenization of the input, such as deletion of comments and compaction of consecutive white space characters into one. So after reading the source program from left to right, so any of these white spaces, new lines, comments, etc., those can be identified and removed. Then lexical analysis proper is the more complex portion, which produces tokens from the output of the scanner. That is, output of the lexical analysis scanner is nothing but tokens only. So sometimes the lexical analyzer are divided into a cascade of two processes. First, scanning, which identifies the comments, white spaces, and then deleted. Then it identifies the tokens, which is output of the lexical analysis or scanner. Then you can see the comparison between or the relation between lexical analysis versus parsing, also called syntax analysis. So there are a number of reasons why the analysis portion of a compiler is normally separated into lexical analysis and parsing pages. This is one of the questions sometimes you will ask. So why lexical analysis and parsing are separated from the analysis of the source program? The analysis of the source program consisting of 4 pages: lexical analysis, syntax analysis, semantic analysis, intermediate code generation. So why lexical analysis and parser or syntax analysis are separated from the analysis portion of the compiler? The reasons are, so simplicity of design. Simplicity of design, whenever you can separate these two from analysis portion, so which is the most important consideration. Then compiler efficiency is improved. Then compiler portability is enhanced. Portability means so compatible to run in any system, operating system. So these are all the reasons for separating lexical analysis and syntax analysis from analysis of the source program. So these are all the interactions between lexical analysis and parsing. Now let us see the definitions and examples of the 3 important terms: tokens, patterns, and lexemes. So token we already know, which can be defined as smallest logically cohesive sequence of characters of interest in the source program. A lexical token is a sequence of characters that can be treated as a unit in the grammar of the programming languages. A token is a pair consisting of token name and an optional attribute value. So during the lexical analysis phase, at the time of phases of compiler, we already discussed a token is represented as a pair consisting of name of the token and an optional attribute value. Then let us see some of the examples of tokens. So one of the examples is called as type token. For example, identifier, number, real, etc. These are all called as type tokens. Then punctuation tokens like if we have if, void, return, etc. Then alphabetic tokens, for example, keywords. So these are all some of the examples of tokens with their category. Then some more examples you can see related to operators and constants. So single character operators, you can take single operators equal, plus, minus, greater than, less than, and so on. Then multi-character operators. So that equal again considered as multi-character as well as single character also. Then double equal, not equal. So then minus, greater than, minus, less than, etc. like. Then keywords if, while, etc. Then identifiers like my underscore variable. Identifiers are named with a single string. So if any string consisting of more than 2 words, you can take hyphen, not hyphen, underscore with a single name. So my underscore variable, flag 1, my underscore variable with a different nomenclature here, M, V or capitals. So these are all the identifiers. Then numeric constants or literals like 1, 2, 3, the digits. Then some floating point numbers 45.67. Then some exponent values 8.9 power. So point positive 0.5. So exponent values. Then some character literals with single quotes, single letter or character. So within double quote. Then similar symbol within double quote, slash within double quote. So within single quote, whatever the characters or literals you can include, those are all also tokens. Then string literals. So within double quote, you can include a string. So combination of more than one character. For example, ABCD is a string. So which can be represented within double quotes. These are all various examples of tokens. So now some of the examples of non-tokens. So now comments, preprocessor directives, macros, blanks, white space, min space, tab, end of line, new line, etc. So these are all non-tokens. So sometimes they will give one source program. They will ask to identify the tokens and the non-tokens. So at that time you can see all these. So in any source program, comments, preprocessor directives, macros, blanks, white space means space, tab, end of line, new line, etc. These are all not tokens. These are all non-tokens. So other than this, the tokens are identifiers, keywords, constants, operators, etc. And above, whatever the examples we mentioned. Now let us see definitions of each and every of these terms. First, a pattern. How to define a pattern? A pattern is a description of the form that the lexemes of a token may take. So lexemes of a token may take. Lexeme is nothing but the given characters in the source program. So then, so what is description of that lexeme? That is nothing but a pattern. A pattern is described as a rule describing set of lexemes. So examples of patterns are, so keyword is a pattern, identifier is a pattern, relational operator is a pattern, and some symbols like the hash, dollar, open brace, closed brace, different types of brackets, then colon, semicolon, etc. So now here you can see keyword. Actually, what is the keyword? This pattern specifies a token. Keyword is a token. So it has some definition. Keyword, what it contains. So keyword contains some reserved words. Then identifier, it has some definition, some pattern, some structure. What is the structure of identifier? It must start with a letter followed by letter or digit. Then relational operator is a pattern which has a structure which consisting of the relational operators less than, greater than, not equal, 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 or single less than, greater than, etc. So these are the standard operator. Then symbols, any of the symbols you can take. So every pattern having some structure. So that's why a pattern is a description of the form that the lexeme of a token may take. So every token may take that pattern, that structure. So now, how to define a lexeme? A lexeme is nothing but a sequence of characters in the source program. In the source program, you can take the sequence of the characters in the given source program that matches the pattern. Pattern means like a identifier, an identifier or keyword or constant or number or relational operator, etc. Then that matches the pattern for a token and is identified by Lexical Analyzer as an instance of that token. So tokens are identified by using lexical analysis only. Then a lexeme is a string of patterns read from the source file that corresponds to a token. For example, here you can see, so your given source program contains character, string, left bracket, right bracket, equal, then a string hello, then semicolon, etc. Now, all the characters you can take in the form of sequence, some conjugative characters. So that is a lexeme. Why you have to take conjugative character means further that lexeme defines a pattern for the token. Now character, you can see character, what is this one? This is actually a keyword. Then str, this is an identifier. Left bracket, right bracket. So these are all symbols. Equal is the operator. Hello is the string. So these are all the lexemes. Each lexeme defines a pattern for a token. So then let us see one example. The source code or the input program is given like this. Character str, which is the method defined as array type, then equal to hello. Hello is the string which can be represented within double quotes. Then ended with delimiter, that is semicolon. So now here character, which is a data type, then str is the name of the variable or identifier. So then with array brackets, then equal. So now from this source program, here you can find out patterns, lexemes, and token. Here clearly you can get the difference among all these three. So lexeme is nothing but as it is in the given source program with sequence of characters. So first you can take char is one lexeme, then str is another lexeme, then left bracket is another lexeme, right bracket is another lexeme. All you can separate one by one. Then equal is another lexeme. Then hello within double quotes is another lexeme. Then semicolon is another lexeme. See, lexemes are nothing but the sequence of characters in the given source program. As it is, you can write down. Now, pattern means the type of lexeme. So, the description of the lexeme is denoted by the pattern. Like finally, that pattern gives a token. So now you can see char. What is this one? Actually, this is a keyword. Then str. What is this one? This is an identifier. Then left braces. This can be the description of this symbol is called as left bracket. Then this is the right braces. Can be written as right bracket. Then this equal symbol. This is actually an operator. What is the type of the operator? That can be defined in tokens. Then hello is a string. Then semicolon is a symbol. Here you can see the lexeme's description is nothing but a pattern. Now the tokens are represented by uppercase letters with a combination of token name, comma, an optional attribute value. So now here for the Lexum CHAR, the token is same with uppercase letter CHAR. Then for identifier STR, this can be denoted by ID, comma, one is the attribute value. So this is attribute value, which is optional. Then ID is the name of the token, the type of the token identifier. Then left bracket, so the token is left underscore bracket. Why? Because the tokens are unique names, single names. So that's why left bracket can be so combined using underscore. Then similarly right bracket, right underscore bracket. Then operator, what is the actual type of this operator? Assignment operator, ASSIG underscore OP means assignment operator. Then addition operator can be represented as ADD underscore OP. Multiplication operator MUL underscore OP, like that. Then the string can be represented as literal, the type of the token. Then symbol semicolon can be written as semi underscore colon. Now we can see for this source program, the patterns, lexemes and tokens are identified. Like any given input program, you can identify all these three: patterns, lexemes and tokens. Sometimes in examination, you may get this question. They will give one program. Even they will give one simple C program. From that, you can identify patterns, lexemes, tokens, like that. You can read one by one. Then you can group them into lexemes. Then you can provide description of the lexemes as the pattern. Then the tokens are represented with token type followed by optional attribute value with uppercase letters. So then attributes for tokens. So when more than one lexeme can match a pattern, the lexical analyzer must provide the subsequent compiler phases additional information about the particular lexeme that matched. So whenever more than one lexeme can match a pattern, then the lexical analyzer must provide the subsequent compiler pages additional information about the particular lexeme that matched. For example, the pattern for token number matches both 0 and 1, let us assume. But it is extremely important for the code generator to know which lexeme was found in the source program. So for this purpose, so the lexical analyzer provides the subsequent compiler pages with additional information. So thus in many cases, the lexical analyzer returns to the parser not only a token name, but followed by attribute value to overcome this problem. So the attribute value which describes the lexeme represented by the token. The token name influences parsing decisions further, while the attribute value influences translation of tokens after the parsing is done. So that is the importance of attributes for tokens. The token names are basically integer codes represented using symbolic names written in uppercase letters such as capital INT, capital float, capital semi underscore colon, etc. Just now in our previous example, we saw all these. Then the attribute values are which are optional and will not be present for keywords, operators, and symbols. Only these are all presented for attributes. So these are all the attributes for tokens. Let us see one example. The token names and associated attribute values for the Fortran statement E equal to M into C power 2. This is nothing but our famous formula E equal to MC square. So this can be written as the square can be expanded with double asterisk operator, then multiplication operator using single asterisk. So now this is the statement related to Fortran language. So are written below as a sequence of pairs in the form of tokens followed by attribute values. This can be written as first one E. What is E actually? Identifier. So ID comma then pointer to symbol table entry for E. This is nothing but attribute value. So here ID, sometimes capital ID also used. Then other one, next symbol is operator. What is that operator name? Assignment operator. ASSIG or GN underscore OP. Here for operators, keywords, attribute values not included. Only for identifiers, attribute values are included. Same thing can be written as with uppercase letter also. Then another one is M. M is other identifier. So ID comma pointer to symbol table entry for M. Then next one is multiplication operator asterisk. Can be written as MULT underscore OP or uppercase letters. So the operators won't contain attribute values. Then another one is C. C is other identifier ID comma pointer to symbol table entry for C. Next, what we have double asterisk, which is exponent operator, can be written as exp underscore op. The operators won't contain attribute values. Also written with uppercase letters. Then the last one, 2, digit 2. So what is its token name type number? So then its integer value is 2. So here this is attribute value. So except operators for constants and for identifiers, it includes token type followed by attribute value also. So this is the one example of attributes for tokens. Then moving to the last topic in this lexical analysis, lexical errors. So it is hard for a lexical analyzer to tell without the aid of other components that there is a source code error. For instance, if the string fi is encountered for the first time in a C programming in the context, that can be defined as fi is a function. So within function, the argument or parameter is defined as a equivalent to f of x. F of x is a function. Now a and x are identifiers. So here we are talking about fi, the string fi. So we don't know actually what is fi here. So the program shows error by reading this the fi string. A lexical analyzer cannot tell whether fi is a misspelling of the keyword if or an undeclared function identifier. So the lexical analyzer can't describe whether it is misspelled or a keyword if or an undeclared function identifier. So since fi is a valid lexeme for the token ID, the lexical analyzer must return the token ID to the parser and let some other phases of the compiler, probably the parser in this case, handle an error due to the transposition of the letters. So like the lexical errors are encountered during the phase of lexical analysis or scanner. Then how to overcome, how to handle these lexical errors? Suppose a situation arises in which the lexical analyzer is unable to proceed because none of the patterns for tokens matches any prefix of the remaining input. So in this, some of the recovery strategies are used. One of the simplest recovery strategies is called as panic mode recovery. So what is the role of panic mode recovery? So delete successive characters from the remaining input until a lexical analyzer can find a well-formed token at the beginning of what input is left. So this is panic mode recovery method, which deletes successive characters from the remaining input until a lexical analyzer can find a well-formed token at the beginning of what input is left. So this recovery technique may confuse the parser, but in an interactive computing environment, it may be quite adequate. So this is one of the error recovery strategy to handle lexical errors. There are some other possible error recovery actions also. So some of them are delete one character from the remaining input. So their panic mode recovery is successive characters are deleted. So but delete one character from the remaining input. Then insert a missing character into the remaining input. Only one character can be inserted wherever the characters are missed. Then you can delete only one character. Then replace a character by another character, one character by another character. Then transpose to adjacent characters. These are all some other possible error recovery actions used in lexical analysis to handle lexical errors. Okay, now let us move to the summary of this lecture, what we covered till now. So in the role of lexical analyzer, we discussed lexical analysis versus parsing, Then the role of lexical analysis with the diagrammatic representation. Then we discussed about tokens, patterns, lexemes, their definitions and examples. Then attributes for tokens. Then lexical errors. Then various error recovery methods like panic mode recovery, etc. So next topic is input buffering, again related to lexical analysis or scanner. For this topic, the reference is AHO 2 second edition, section 3.1. Okay, now I stop here. Next class will come up with our new topic, that is input buffering.